Check in. I think we're live. Let me verify that quickly. Yeah, we are. I will quickly check the sound. Public, hey, how are you?
Hey, doing good, Alex.
I think
Thanks.
we're live.
How's the
Let
sound? How's it
me
going?
verify that quickly. Yeah. Yeah, we are. I will quickly check the sound. Public, hey, how are you?
Traditional question. Doing good, Alex.
I think
Thanks.
we're live.
How's the
Let
sound?
me. Yeah, sorry. It was, it's so brain consuming, like seeing you in two different places and hearing you in two different places simultaneously, and verifying sound and reacting to what you're saying. But all good. We can go on.
All right, that's nice to hear. Traditional question: can you share the link to the stream in the Meet?
Yes, makes sense. Yeah, let me do that. Yeah, so the link, I will post a link now to our workshop that we started last week. The link is xtechnology.dev/rag. So yeah, this is the overall workshop that we've been going through, and the last time we kind of covered the first part of it. So we decided to go early today. So good afternoon, everyone, and hope you enjoy your Friday as we do.
And traditional question: where did you post the link?
In our that's I need to share also the video, I guess, video link with you. Yeah, that one I will share in the chat, in a private chat, I mean. So really good Friday for me, hopefully for you too. So let's maybe remind us a bit what we're doing here. Let's start with that. I think it's best if whoever is watching this, and I saw some people watch this on YouTube, so hopefully you enjoyed it. This is a workshop we preparing for the conference, not Congress, to be precise, and that is coming this week and the next week in parts of workshop. So the workshop that we preparing is called Building a RAG System in Node.js. It's a Node.js conference. So in this workshop we're trying to explore what it takes to build one system, like a RAG enterprise RAG system. It feels like it is called right now. Basically, it's using LLM for your private KBs to answer certain questions about data that you have. This is the workshop link that we have posted, and we've been through quite a few parts already. So actually we covered this amount last time. So I think today we're gonna finish it, and I think we're gonna be a little bit quicker than the last time. Just to summarize it a bit, of course, I'm not going to introduce ourselves. So we've been through like what the general terms of technologies that are used in Retrieval-Augmented Generation system. And then we also talk that, what you need to build one. For that, you kind of you can imagine this simple function. You need to somehow prepare the search function. You need somehow to retrieve documents that in this search function, and then you need to pass these documents or parts of these documents into making a prompt, like a real prompt to LLM. We said also that LLM is a main part in this overall system, which will be sending the actual response to a user, but also it helps in the intermediate steps, like helping analyze, to helping find the most relevant data from your knowledge base. So after you making a prompt, you basically rely on LLM to give an answer. And that's what you return to a user. We also explored the different considerations that this system might be useful to take into account. things like cost. I think that's one of the most important, but also overall user experience, let's say, how slow it is. Then we explored the few practices. For this one, public, I'll give you a word maybe.
Yeah, so we did a couple of exercises, like just to get a little bit of touch what we were talking about. So the first one, we were trying to, like we made the first call to our LLM, successfully got a quite weird response. Well, it is a response generated, but not the top not notch model, but the response was generated, so that was sufficient for us. After this, we continued with the explanation or learning what is the RAG and how it works.
Yeah. For our use case, we parsed a bunch of RSS feeds, and then what we're trying to achieve is something like this, but this is a nice view from Atlas system, so we have more like like a text interface instead. How do we scrap articles is really not important for this workshop. But then we discovered how we can store these documents in our databases, and for that we also talked about technique called chunking. So we said that it's important, and it might be bringing more quality to store your documents as a piece of chunks in your database instead of the whole documents, because of reducing noise and enhancing retrieval precision, things like that. We explored this chunking, what are the techniques, the common techniques I used. Like you can imagine, there are more than one way of chunking your documents, splitting your documents into part. That's basically where we stopped last time with the practice of chunking. And I just wanted to finish on this one. We said that for depending on your use case, when you build a RAG system, if you build in a chatbot, for example, that needs to answer users' questions, then what you can do instead of algorithmical chunking, you can basically ask LLM to produce relevant questions that will help you to retrieve relevant documents and afterwards find the best answer or generate the best answer to a user. But there are, of course, many more. So Public showed us different chunking strategies. And also, Public, please post a link to our GitHub so people can also enjoy that one and start this project locally if they want and see how it works for them. Nice. So that's in short what we did last time, and we stopped at the store and retrieval. So I think let's go on. Let's start with that. We at this point we already have documents parsed. Let's come back quickly to this main function that we started with. So we still stopped kinda on this first line. Like we still want to understand and implement this search functionality. And we said that we can rely on some databases, and we gonna store chunks of our documents in this database. Then a question is, okay, but how do we really store them? How do we really retrieve documents? And for that, the main technique that is used in the RAG kind of systems, it's called the embedding. It's a technique of representing your document as a vector of float digits or just digits. And it's not only that; it's more than that, of course. There is a question like, do you need embedding at all? Let's explore it a little bit. To be honest, when I got my degree in computer science, my main work, like the work that I did for diploma, was something related, and we didn't know what I didn't know what embedding was at this point. But what I did, developed kind of search system, like Google, but a little bit less. I explored this topic as well in my student years, like how do I transform a document into vectors? And basically, the idea is quite simple on a high level. First of all, you need a dictionary of all the words that appear in a language. So for English language, I read an article recently. I think it depends, of course, how do you count. There are like different most common words that I used. There are also different accent words, like or specific words that I used. But the overall amount of words in English language is from 200,000 to a million. So that's a range. Like the rarest words and with different counties that can be up to a million words in total for English language. So that's huge. And imagine you need to represent somehow your document in this dimension of 1 million points, of 1 million how it's called again, dimension of 1 million. For that, the most obvious way to represent your document is basically, it's also I learned recently, it's called one-hot encoding. Like basically if you find a word in your document, then you basically say, oh yeah, that's a hit, and you put a one on a hit here. So let's say king here is just a word in a dictionary, and it's still the dimension is quite huge, right? Up to a million if it's talking about English. But then there are certain problems with this, with storing and retrieving that. With storing is obvious, like that takes a lot of your storage, so it's gonna be costly, and it's gonna be ineffectively when you compare it for relevance and for you try to find something similar. That's one kind of problems. The other kind of problems is that some documents, when you try to measure how close they are to each other, the words might be not close at all because it's one hit encoding, like there is a king and queen, they are not relevant to each other, but semantically they might be still relevant, and for that you might use some algorithmical approach. Again, you can find dictionaries of synonyms or dictionaries of different context, close semantic context or whatever, and then you can do this I don't know, transformation of your vectors. So they first of all take a little less size, and second they also take into account the semantic of the wording. Also, you don't want to have a different stop wording in your document. Things like and, of, and other words that I use during this talking as well. So you probably don't want that. So for that, what you can do afterwards as well, like. There is a word embedding, like that basically a way to shrink this overall dimension into some smaller dimension. And what is that? In my search system design, or in my search system implementation a while ago, I used a technique called SVD. That was, I think that stands for singular vector decomposition, but that's like algebra way. You got the whole matrix of all your documents stored, and then your sparse, I think it's called sparse space. You reduce it by saying like, oh yeah, we don't need zeros, and then there is a algebraic, I don't know how to say it, way to just cut it out somehow. So basically transform your original huge matrix into a smaller one without knowing what is inside. So that works nicely, and I think many systems up to some point used this and relevant algorithms as well. The embedding is quite similar to that, but instead of doing really algebraic, theory-based transformation, what it does, it actually uses different models to train on a set of data and set of dictionary, and the knowledge base is basically the whole internet and what is known to human history. So based on this data set, it learns how to transform your huge vectors of text-based documents originally into a smaller dimensions. Like you don't know what's happening under the hood. Basically, what we know is it shrinks the dimension significantly, and that's what appears on the right side of this picture. Basically, it goes from one hit encoding into something that contains multiple hits in the vector, and you even cannot explain what are these numbers inside these vectors. It's just depending on the model that you used and that was trained on the text data set, and it can also differ for the output dimensions. You can, in certain cases, you can select yourself the dimension. So that's in short what embedding is a vector representation of data in embedding space. So projecting high dimensional space of initial data vectors into low dimensional space. Hopefully that makes sense. So alternatively for that, you can still use keyword search, like that was a semantic search kinda. For the keyword search is basically one hit encoding. Like if you search by king keyword, you will find documents that contain king. But for semantic search, because it also takes into account all the synonyms or relevant context, you might get the queen in documents that contain queen instead of queen, but that also shows how close this context is to each other. So that's how we transform like our original text documents into vectors, and then we also shrink dimension by using embedding technique. There is a nice article and nice Google course online and also free, and so I encourage you to read this document about embedding. They really have a nice picture of these dimensions. How do you how you can represent different foods into multiple dimension there. So it's funny, and also it's quite given some thoughts. Nice. So how do we use these embeddings? Like, do we need to implement them themselves? Well, probably not. Like, we're gonna use LLM, and we're gonna use some embedding models. There are a lot of them. You can find in Hugging Face, Python-based models mostly. In Ollama, because we use Ollama in our workshop, there are supported models already. So we gonna explore one of them, I believe, today. You can read about like what are the most different metrics, what is the best performance, like what is there are different metrics and different playgrounds where people have a set of documents and try different models and set the performance mark to a certain point. So there is a whole competition between these models, and sometimes they're also costly in terms of time execution. So yeah, you can read about different features that might affect your final application. There is one question before we go to practice. Maybe public, we can discuss it a little together. Like the question that you asked me to add and the answer to that. Like, okay, we indexed our documents, we store them in database, and we store them already with the embedded technique. And then the question is, okay, can we actually switch our embedding model at this point? And I think the answer is obvious. The models are different, they're trained differently. If you indexed your document with one model, it's gonna be one set of indexes or one set of float numbers, and that just won't work for other models, because what happens here is under the hood of the model training. It depends on many factors, and no one actually can tell you what these numbers mean in a vector representation. Is it true, public, or not? Do you agree?
Yeah, definitely. If you say so, then I definitely believe you. So
Nice.
I guess it's true. And like based on what you explained, it's absolutely like from the fact that you don't exactly know how this model represents the text internally, like there is no guarantee, even though in theory it might be possible. Like it's there is a chance that somehow one model decided to represent the internally like documents as another, but I don't think that is like realistically we should count on this.
Yeah, true. Yeah, maybe at some point, there will be some standardized models that can use. You can just switch between them. Yeah, but I really don't know how to implement that. If you want to still have different models based on different technologies that I used, and yeah, still having comparable indexes.
Yeah. But anyway, let's continue with the practice. And indeed, like the current practice is for storing the documents and retrieving of the documents. In the highlighted code on the screen, you can see that it's await chroma dot from texts, and this chroma keyword or the class in this situation, and this is the database that we are going to use. Alex mentioned that like there's eventually those are vectors, and based on the similarity is based on the distance between the vectors, and basically therefore we need like to have a storage for the vectors, and that might be like literally from just store the vectors in memory, and we can, after like the restarting of the application, we will get a new vectors every time, which is not actually that much different to what we have in the workshop. But you can also store the vectors in the database, which is way more nicer because you basically don't need to regenerate them. And indeed, like model to put the vector, to convert document to vector, model will do some work, which obviously costs time, energy, and money. So let me then try or share the screen.
Yeah, please do. Yeah, I totally forgot to mention, indeed, how do you measure the closeness of the documents? You can use dot product or cosin product, let's say. So cosin is basically how you calculate the cosin between vectors. So you can implement it yourself with just writing a function. Yeah, Pavlik.
Yeah, I was waiting for you to finish, and here it goes. As I already mentioned, we are going to use Chroma as our database. You can use some other databases like Elasticsearch, supports vector storage. Probably like you can even put to directly SQLite. So there are plenty of them, and essentially Chroma is based on SQLite. So it's you will have eventually a file where all the embeddings and the vectors are stored, but it just provides a nice interface to work with it. So as the first step, we are going to install Chroma DB. Very simple. We go to Chroma. We go to get started locally, and that is essentially it. We can switch to the TypeScript, but essentially to install the Chroma, we need to run pip install db install Chroma db. Not Chroma. I did this mistake multiple times. If you just do pip install Chroma without a db, then you will install syntax highlighter for Ruby. So that's a little different package.
Still useful.
Yeah, still useful. But we need like the Chroma DB. Since I already have it installed, it's like this is not going to do anything. But afterwards, we also need to run it a little bit. And I'm also going to enlarge the font. New line, right? Wow. Yes. Yeah, so it says that I have outdated pip, which doesn't really matter, and it says that everything else is installed. And for the chroma, we are going to run it like this. Chroma run. Nothing like really fancy. Then we have document storage documents, but first of all, we need to create the collection. And for this, there is a special script which is setup chroma. This special script will generate some embeddings, will load some documents, and create a collection which called rack node workshop articles. And this collection, we are going to use this collection during the workshop. Let me just quickly check that everything is still fine here. It seems fine, and the chroma started. It serves the files from the local folder, either chroma or chroma data. And then we run our setup, which exists as the script, and it's npm run setup. So this probably this might fail, I think. Yes. So this might fail because I don't have OpenAI key in my .env, and I will put this, but I will stop sharing for a second.
And you just showing it in order to show how to connect to OpenAI embedding model.
Yeah, that's this part of the workshop. I forgot to actually migrate to
Llama.
Llama, yes, and actually that's fine. We can do this on the fly, and I will just show how to basically use LLM to do the work stuff.
Yeah.
But for this, I will ask you for a little bit help, Alex.
Okay.
Since this is the working laptop, I don't have access to my LLMs.
Okay.
And therefore, I will ask you to copy a piece of the code, to paste it to ChatGPT or Claude, and to ask it to migrate to Llama with the embedding model.
We don't need it to do. If we want, we can just do it with OpenAI. But up to you. I do whatever you say.
Yeah, we can do this with OpenAI as well. If you have key locally, then we can do this with OpenAI as well. But for this, I will ask you to share the screen. I stopped sharing.
Yeah. Okay. So once again, like what do you want me to share? That code?
So if you have this workshop locally, and you can share this the screen, how you essentially going to run setup chroma, and this will install chroma and generate embeddings for some documents. And if not, I also can copy this piece of the code on the fly from different folders and generate embeddings based on Llama, but it will take a little bit more time than just run this.
Yeah, it's fine. I can do that. I just probably would need also do the same, like essentially put my OpenAI tokens. So let's see. Yeah, VS Code is visible. Okay. All right. Okay. So yeah, I have a workshop here. What should I do next?
So 1 second. Yeah, so you can do npm install if you didn't do it yet.
No.
And then you need to install chroma.
With pip, right?
Yeah, which is pip install chroma-db. And does it do anything?
It did install It says also installing collected packages. Error pips dependency doesn't currently. Well, it says it's installed it. Now let's.
All right.
Mm-hmm.
Yeah, that's good. Then now you can do you need to create also .inf .env document with the OpenAI key.
Okay.
Yeah, now it's your time to stop sharing for a second.
Yeah. If I do it like that. I'm just trying to open it in a different window. How do I do that? I think I can do it like that. Okay. So now we're gonna try to use OpenAI LLM, right?
Mm-hmm.
1 second. It's interesting. It doesn't want me to open. Yeah, now it's better. So if I do it like that. Okay, that worked. Let me check quickly. OpenAI, and what is a key name for? Do you remember that?
I'm checking. The key name will be open_API_key. OpenAI API_key.
OpenAI_key.
API_key.
Okay. So now I'm gonna retrieve my OpenAI key. One second, almost there. I can also share it, do a really temporary key. Maybe someone will, who's watching us online, can use it. Create new secret key. My test, how it's called, RAG workshop temporary key. Create secret key. Yeah. Let's see that. Yeah, I've done that. OpenAI key pasted now. Yeah.
Now you need to start Chroma. For this, you need to open new terminal. I hope, and then run ChromaDB run. No, Chroma.
ChromaDB run.
Just Chroma.
Okay.
You're not all set. You can now do npm
It
run.
says I need to specify the database probably for that. Something -d maybe Chroma data or something like that.
Did you run it from the project itself?
Yeah, it's from a project, yes.
Okay, so you need to do Chroma run. I see now that you just did.
Okay. Okay.
Yeah. So now, yeah, you can just do npm run setup, and we will see.
npm run setup. Let me check. What is it doing? Maybe it's pasting my OpenAPI key to some setup. Well, I won't recognize anyways what it is doing inside.
Don't worry, it doesn't. It just starts the Bitcoin miner.
Okay. All right. I love it. No, it says it cannot use connected to Chroma database access and collection, couldn't connect to tenant, default tenant.
tenants. This is the ChromaDB, and the ChromaDB does run for you. What is default tenant? 1 second, let me check the script. Connect to ChromaDB. Collection name, let's list collection. And connected to ChromaDB, yes. Connected to ChromaDB. Okay,
Maybe
so
I should create collection first. Like, is it inside Chroma data already, the collection, or should I do some kind of?
yeah, but the thing is that like the collection is created by default for you. But let's just check on what port the Chroma is running for you. If you go to a different terminal where you ran Chroma,
should be 8,000, I think. Yeah, 8,000. Like.
But if you go to the previous terminal, where 8,000 is like it's really says in the terminal.
Okay, yeah. So what do you want to do? Like it says some Python is running. I think it should be Chroma.
Yeah, you're right. It's a type. Collection. But let's try to comment out all the code in the setup Chroma.
In the meantime, I will also ask Copilot what the guy thinks about it. Yeah. So what to run? Sorry.
So in the setup Chroma, please comment out everything from the line 41 to 52, and then from 61 to 65.
Oh my God, 41 to 62.
41 to
65.
To 1 second, no, to 52. Yeah, and then from 61 to 65.
I got it. So remove the try catch block. Okay.
Yeah. So this is supposed to create the collection, and then you can also remove. Yeah. Let's just run this one.
Yeah, it's if I change here. Okay, so this is type CommonJS. Why does it think that it's not CommonJS then?
I think you need also one more. Oh wow! So you need to one bracket is not correct, or does it?
Oh yeah, it shows something here. Yeah, that's true. So what did I change here? Once again. Yeah, got it. Yeah, it should be fine now. No, it's still the same.
It says that await async is not possible to do.
No, it says could not connect to tenant default tenants.
All right. Let me think a little bit. Yeah, so what does it say? It says default tenant database.
Yeah.
Do we like we don't need to create any databases, I think. Let me think. So I can also see the Chroma itself also does not say that anything needs to be run after we install and we run it. And the ChatGPT or Copilot, what does it say?
Not super useful stuff. It says check if default tenant exists. check if Chroma is running. Yeah, for checking if the tenant exists, we might want to use kind of CLI for Chroma.
Let me try to copy also comment out the code that we commented out on your machine, and then I will run it on my machine, and we'll see what will happen. Generate, query the collection, this we don't know. Yeah, that's a little bit strange, but let me share then my screen. I will show it how it looks on my machine. All right. So the Chroma is running. It also runs on the default 8000 port. Then the workshop, yeah, I commented out all the code is related to OpenAI. So now it only essentially like checks for the collection. It says that there are no existing collection, and therefore it creates a new collection, RAC Node Workshop articles. And if I run it again, and then it says that the existing collection does exist, and therefore it does not do anything. So that's essentially how it should look like.
I can have an idea. Maybe I can give you my OpenAI key in order to proceed.
We actually don't need, because this setup Chroma is only needed to create the embeddings, because then, or sorry, to create the collection. Because the actual stuff is then document storage and embeddings, and I can just like proceed from there. Okay. Yeah, like essentially, as you Alex showed, the collection that we are can use is nomic embed text. So yeah, this is the like probably one of the smallest model that you can use to generate embeddings based on the Llama. So as always, we do Llama pool and the name of the model. And as always, because I was preparing for this workshop, I do have this model, and as always, I forgot that it's a different laptop, and on this laptop I don't have this model. So it's a good thing that I tried to download it, and it is downloaded because it only weighs almost 300 megabytes. So essentially what it does, it's like we have get embed model, and then generate embeddings, which takes the embed model and converts it to a text. And where is this used? This is used nowhere. Okay, but this one, get embed model, is used in our main file. Main file index.js is like the entire workshop, but we can comment out the second part and just do the store. Yes, this one is we need. Store the embeddings in the database. So as you can see, it connects to Chroma on the well-known articles or report. It uses this RAC Node Workshop articles collection. Before every run, we remove this collection, and the idea of it, because we want to test different implementations, evaluate different models, for example, and as Alex already mentioned, different models for embeddings are not compatible with each other. So if we are going to use a model for the small model, or as like OpenAI model, or a small model from Llama, or a different model from Llama, we just like easier for us, it's to delete the existing collection and recreate it from scratch. So then we have like creation of the vector store, and in the vector store we put the chunks of the text that we split by tokens, and the splitting we already studied in the previous example. So essentially that will look like this: npm run start. So in the very beginning, it will get some documents, split them, and then put them. Oh my god. Llama also wants to start. Llama, sure. Wow. And here I also have very similar error with the default tenant.
Yeah, well, you have document retrieval and splitting now. That's before, right?
Yeah, but yeah, that is super interesting now, because it's 1 second. So I will check what's the difference between the Chroma setup, which does exactly the same client, and this one. Document retrieval, document splitting. Document splitting goes here. Split by documents, yes. Embedding generation, and then that is. I can try to restart Chroma, which I don't believe it like will help anyone anyhow. No, that is the same. And if I now do the setup, wow. So setup does work, and the Chroma client here is from ChromaDB, and here Chroma client is from ChromaDB. Okay, and the path is identical, I believe. Yeah, the path is identical. What if we try to list collections here? That's okay.
No, fetch file is a different one.
Yeah, at least it does show existing collections. And the fetch field it's on Llama, which is okay, but I will just start it a little bit different. No, Llama, you can stop. So that's supposed to work now, and let's check again. Wow, it is cancel. So somehow, sometimes it does not connect to Chroma, and sometimes it does.
Yeah, it's weird.
No. But not anymore.
No.
Wow. Let me check once again the setup code. All right, so okay, so last time we did delete the collection. Yeah, that's apparently, it's like the issue is not actually with the database. The issue is the fact that the collection might not exist. So I will just put it inside the try catch, and that's supposed to be fine. All right, so this solved one problem, but another one is Olama, which is not really working on my machine at the moment. And
Okay.
I need to start it with apparently root or update it. Let me just check one quickly.
Mm-hmm.
Du- du- du. Open. All right. Olama. Yeah, so that's supposed to run now, does it? Um, yeah, so it does work. And let's check one more time. Run start. No, so Olama does not really work. Okay.
That that happens all the time, you know. Like when we
Yeah, but that's yeah, that's really strange that suddenly everything stopped working, like literally.
maybe
That
maybe a new package came in recent days, and you know.
yeah, what I'm afraid is that what happened is yeah, my my laptop restarted, and like all the applications got closed, and now they cannot be opened again.
Mm-hmm, mm-hmm.
Yeah, that's super annoying. Yeah, I I did start Olama, but I don't think that it's going to run.
Mm-hmm.
No, it's the connection refused. Well, yeah, if you have run in Olama, then that will be working for you, hopefully, and I will need some time to actually, yeah, update it and restart and install from the scratch from probably.
Mm-hmm, mm-hmm. Let's see. You can see my screen now, right? So it's Olama surf, right? And then we do pull for a specific model.
You can even just start Olama on just
Yeah, or just interface.
yeah.
Yeah, I think it's already running. Yeah, for me. Mm-hmm. Yeah, I already started it.
So if you do, uh, yeah, okay. So that is. Yeah, but like the whole thing is that Chrome is not really working for you probably. But let's try. So if you do npm run start, let's see.
Mm-hmm. Oh, it's still default tenant error.
Okay. Well, then I will try to do something with my llama. Okay. It says that this address is in use, and I do start. Wow. Okay. Let me try to maybe run this model. I don't think that it's going to change anything for Llama, but just in case. Yeah, so I do see that from the terminal my Llama works. My so I'm curious what. Yeah, 11434. Let's check. Maybe the error is a different one. So actually it says that the Llama is running. But during the workshop it cannot connect to it. Wow. Let's try to change the... Maybe it's local host is...
Oh, can it be a 0000 thingy?
Yeah, I'm trying right now. Yeah, like this pm run start. No, address is the same local host or 20 001 28001. No, so it's the same. Connection refused. If I run it from script, but in bash it works. Wow. So let's just continue without the practical part. Practical part I'm going to tell on the theoretical level without running it, at least for this time, and till the next time I will fix it. We'll try to fix it.
That's good. Let's do it like that. Yeah. Yeah, I can tell me what to do. You can also share your screen.
Yeah. So let me share the screen. And that looks like it. So what's supposed to happen here? Like the ChromaDB is supposed to connect, and this one is actually connects, and this one works. Then we clear the database at the moment when we run the script. As I already explained, in order to not mix different embedding models with each other. And then essentially we just put everything inside the Chroma with this setup Chroma GB. So this is the key line which does all the magic actually for us. It creates or puts inside the Chroma DB the texts. It generates for each text the metadata of it, and embeddings is the embedded and the model which is going to be used to convert the document into embedding vector, and this vector will be stored inside the Chroma, and that is it. So after like this command or like this function is completed, we will have the vector store which is connected to our storage with all the documents presented as vectors. And this is it. So on this moment, yeah, everything is ready for the retrieval. And then for the retrieval, like it's again, this part is like extensively we use the Chroma capabilities for the retrieval of the documents, of the similar documents. It goes to the advanced RAG function, and the advanced RAG function, one of the first thing it does, it gets the relevant documents, and it gets as an input vector store, which we generated like a second ago, and the query. And the query is essentially also just a text that is converted with the same model to a vector, and then we get as the and like then we get by the Cassin similarity 5, which is the K. We get 5 the most similar documents on this, and that is it. After this, documents variable is populated with the 5 most relevant or most similar documents from the database.
And the Cousin similarity is implemented in the Chroma store itself, or okay, yeah.
Yeah.
All right. Yeah, looks good. Okay. Shall we switch to the other part then, to the last section? Nice. That was quite interesting to see how we're trying to run all these things together. You can stop sharing. I think that would be a bit.
Yeah.
Nice. Okay. This I can also do something like that, I guess. Yeah. Right, last part, it's about re-ranking and evaluation. I think we're gonna keep it quick, short today. So the re-ranking part, just a really high-level explanation what that means. So after we retrieved the relevant documents, and we did it by searching and by checking the distance between the vectors, right? So we got some relevant vectors, we think. And then the question is, okay, can we actually, do we need to improve the search results somehow? And in most cases, when you have a really huge amount of documents and a big amount of the documents that can be retrieved, because in many cases, you have a really lot of data that is kind of relevant to initial query. But then and also because we splitted the documents upfront, that might be that overall documents that we send to user or that we use for generating the user output might be not in the same order as they can be, let's say, for a better performance, for better evaluation in the end. So basically that means that, okay, we got some part of the text. We found that this part of the text in this document is the most relevant by the Cousin similarity. But the text around that is gonna be used for generating LLM output, the real result to a user, in this particular document, is not that relevant as the other documents that might be used later in search. That's why the precision can be modified for a better choice. So for that, re-ranking models are used, and in short, how we can deal with that. Like, okay, we retrieved some number of documents, let's say 5 in Pavlik's example. What we can do afterwards, we can retrieve the whole document, like not only the pieces of splitted documents that we retrieved, and then we can pass all of these documents, like the full context, into multiple. So we can deal with multiple ways from there. Like, first of all, we can do the same embedding model calculation for overall document with the original query, and check then the full document, the full document distance from original query. So that would give us like a yeah, some other ranking probably. We also can pass this all context to LLM question, to LLM prompt, and compare and say how relevant prompting LLM, how relevant is this document to original question. And we can also say, prompt LLM to give us some calculation out of it, right? We can say, how relevant by the scale of 0 to 10 this document is. So it will give us some output, like what LLM thinks about the relevance of this document. We can also use this for re-ranking our documents. There are these kind of approaches that we might want to experiment for improving quality. And then the last step is basically, okay, these all things we were building RAG system, and you can see there are different technologies I used, different approaches, different algorithms, different models as well. Then the question is, which one fits you the best? Like how do we even know that? So that is a part where we do evaluation of our RAG system, and that is basically evaluating all the parts of RAG system. So the search, the retrieval, and the generation, the output. There are different metrics that you can use for that matter. Let's explore a few of them. First, we to understand what parameters we have so far. Imagine all of this, right? We took database. For database, we used a Chroma database. For embedded model, we tried to use Ollama based models. We also tried to use OpenAI models for that. Chunk size is configured right now. For top key documents, we use 5. So 5 documents are currently used for retrieved context. LM temperature for sure will be used, but probably not for first steps for input and retrieval. Prompt template is configured right now, and the re-ranking model is kind of pre-configured as LLM for now. So imagine the questions or the tests you want to write for that is basically what are the given order of the documents by retrieval? Is this can it be better if we use a different LLM temperature or different K documents or different chunk size? So that's that kind of questions that we try to answer in evaluation step. The metrics are really it's a lot of them, and I think they are not defined in stone. Like you can read different articles, and there are different researchers that use different metrics, but they all are around this RAG system. Like all the parts of it, they contain some. You can apply different metrics to these parts. First, is a retrieved context relevant to original input, or is it actually relevant to expected output? Like you can give a template for output that you would give to a user, and then you want to test if the context is actually relevant, like the documents that are retrieved are relevant to the output that we know is truthful. Same kind of can go to order of documents that we retrieve, so we can define, we can mark our best documents up front. There are different metrics. You can apply any of them in this section. Same goes for generation, basically. In this one, we evaluate the, again, LLM model. We can put a parameter there as a temperature, for example. And mostly it's about LLM, so it can be also prompt, quality of prompt itself that is used. So what we want to do is, what we want to measure if actual output aligns with the context that has been retrieved, and the output is also relevant to the original input, so the last part of the cycle, right? Like the output is relevant to input here. So how do we measure that, and what to measure that? What is possible to measure? What is possible to measure, we just said there are a bunch of metrics. We can specify any of those. There are a few frameworks I put here. They are all, I believe, Python based. That basically split this RAG cycle into parts, and you can specify these tests, and you can specify the sort data and the actual data, the actual data that you retrieve from RAG. So they will calculate. That do the rest of work for you. So I'm really wondering how public approach would be looking. So we're gonna know that in a second. Yeah, I don't know exactly which metric we're gonna be using, but just given a hint, give an example, like we can measure, for example, the proportion of queries it retrieves from the at least one relevant document is retrieved for the top key results. Yeah, the hit rate is basically how many queries from like our test dataset got relevant documents from the retrieval model. OVO can also evaluate if the retrieved documents been ranked correctly after the retrieval. Like the first one is truly the most relevant document. Same approach can go for the chunks that we split documents up front, like if this is a best chunk to retrieve, for example. Yeah, and then my favorite question would be like, how do we define numbers? What is good and not good? And I think is the best approach there is you start with some numbers and then you try to improve them. Yeah, like there is no set in stone number that will make all the users happy. So that depends highly on your requirements, on your project, on the documents, the database, and the user queries that you have. So the best is to evaluate the RAG system, experiment with the different hyperparameters, how they affect this ranking, how they affect these measurements, and then that's gonna be improving step-by-step approach, I guess. Yeah, public, let's quickly look at the evaluation that we have.
Yeah, sharing the screen. Still, now it works a little bit more, but still not everything. So that's still, I will go on the theoretical level. Mm-hmm. And indeed, so then the workshop in the index.js, the very last part goes about the evaluation. And in this evaluation, what do we do essentially? So we split our documents into chunks.
And I'm sharing my screen now still. I can go through the code as well?
Okay, it seems that even my sharing now will stop working in a second. So let me give another the last attempt, and if it stopped working, then I'm done for today. So yeah, evaluation. Yes, the sharing died, so please share the screen.
Okay, command my screen then.
Oh, wow.
Is that the correct file? Evaluation-Augmented.js.
1 second. Yeah, that's correct.
Mm-hmm.
So as you explained, we have a hit rate and MRR, which is mean reprocedure score. So the first one, the hit rate, it actually just get an idea whether the document that we want is among the 5 most relevant documents. The second one also takes into account the position of this document in the retrieval set. Mm-hmm. Essentially, like for us, for our use case, we don't really need to know the position. The only important part for us is that the fact that the document is among the retrieved documents. So we are going to focus more on the hit rate. So how do we even evaluate the list of the documents that we got from the database. So the very like obvious way, since we are working with the LLM and everything is based on the LLM, is to use LLM to help us with the evaluation. So, and like the idea is that we have a piece of the text. Then we ask LLM to summarize this piece of the text, and they keep as many words from the original text as possible, but make it concise. So now we have one-to-one representation of the big chunk of the text and its summary. The summary is way smaller. Like, let's say the summary is, if original chunk is 500 or 1,000 characters, the summary is up to 256 characters. And this representation, it's like, since it's based on the original text, it means that if we search for this summary for the whole database, we should get this chunk of the document that we summarized. And that's what essentially like we are doing. So we we do the summarization, we search for the database for this summary, we get back the list of the documents, and we calculate the hit rate of this list of the documents. So yeah, like by this you can like literally see how this works for you. And if you scroll, Alex, a little bit higher, and then there is like in the very, very top of this file of the summarization or this document retrieval, it defines the model. And the model is like actually on the line 9 or like 10. Idea of it is that like the most easiest way is to use the smallest model, which is tiny llama 1.1b, and this model, it works like, it does generate the text, but it works very poorly, let's put it this way. And we can literally see it by our evaluation. If we switch model from the tiny llama to llama 3.2, you will see the significant improvement. Why? Because even based on the summarization and based on the vector store, like it's obvious that like the tiny model will make a lot of mistakes in the summarization, up to the point that it does not even understand that it needs to summarize the text, but just starts interpret the text itself. But yeah, you will see by this that like hit rate is very low. It's very, very low because of the summarization. And this is like obvious outcome of it is that the better model, the better the results. But this what evaluation is for, because after some point, like there will be multiple different models that you can use. Like this one, for example, is obvious. The bigger the model, the better. But what about comparing OpenAI model with the Claude model or DeepSeek model or some other like models in the wild? So that's why this evaluation system is very helpful to understand what model eventually you should use.
Got it. Yeah. Nice. That's all right for evaluation. We don't show nothing. Yeah. Then we come closely to end of our workshop. That's a very rough first run. So good attempt, and yeah, you can follow us. You can go to the Node Congress conference next week for our workshop. So that's gonna be it's gonna be much better there for sure, and we're gonna do it at once. Yeah, summary. That's a part that I was about to ask us in the end of a workshop. Like I can maybe summarize quickly what I think so far about this technology and what are the things that we explored in this workshop. I think the main summary for me is that RAG is known of the magic. Like it's a pretty much straightforward system. It actually it does this not many steps and because of powerful LLMs that we have now, it's very common task as well. And basically, the summary for me is that it's not something really difficult to build. It's you have all the tooling in different programming languages ready for you, just to apply it. And you more than that, you have already built-in approaches, like you can go to some providers like Google one, and just to by clicking, put all the documents, and that will provide you a link to with the generated chatbot, which will be used in your knowledge base and producing answers to you. What is cool about these whole technologies is you can cook it the way you want it. It's like you choose any technology you want, you play with databases, you choose like a provider that is good for your prices and things like that. So it's kind of fun to switch all these parameters and see how these affect your overall result. But that's my summary. Maybe Pavlik, what is your outcome?
So far, my outcome is that things can, even though it's like theoretically very, very solid and they worked yesterday, they might not work today. So be careful with this. And on the same time, it's like the whole point is that it's super powerful technique. These examples that we gave, like with the books or like storage, it's everywhere. Like the database or like information storages are everywhere, and if you like with this technique, which actually quite simple. Like essentially what you do, you split into chunks some piece of the information, database knowledge, and knowledge of the database database of knowledge, and then you pass this you store it in the vector store, and you pass the results to LLM. It's very like simple in theory, and it's so effective that I think everyone can or should even use this for their internal storages of the knowledge. And I don't think there is like currently, and the only probably alternative to this is to enhanced or relearned the model, which like specifically has your knowledge built in, but even that does not guarantee you that the results will be precise. While with this approach, they're always precise, because the model literally uses the files, the documents that you pass as an input, and the documents is your knowledge base. So yeah, it's a very, very good technique.
Okay, all right. Okay, then I think that's gonna be it for today. You can again find this workshop at xtechnology.dev/rag. This URL on the top, and follow the links, read these materials if you're interested in, and give us some feedback if you be kind. Please have a good day, and welcome to our future sessions as well.